Hello, hi everyone. Welcome to the Student the Brand channel. So today we are going to discuss about light reflection and refraction practice session. So I many times I explained this chapter. So if you want explanation of the chapter, once check in live classes. Okay, so you can go to the live class and check once. So in the previous class we discussed these points. Sanya, hi, welcome to the live class. So now few more questions, few more important questions uh, related to concept based questions. I'll ask related to concept based questions. Try to do it. The question is: a wall reflect light and a mirror also reflect light. What difference is there in the way they reflect light? Okay. Notion, hi, welcome to the channel. So this is a practice session, complete practice session only. No explanation of topic. So if you have any doubt in particular topic, I will explain. So questions regarding the question and answers we'll discuss. Okay. So we'll discuss about theory questions first. If all questions are covered, then we'll go to the problems. Okay. So then we will discuss. So question number one related to light reflection and refraction. Practice session. What are the use of question number one? What are the uses of plane mirror? What are the uses of plane mirror? So very important. I'm telling. So this question will come for 3 marks. What are the use of plane mirror? So we can go plane mirror. Okay, right? So plane mirror, is it visible? Yes, plane mirror. Plane mirror. So this question expected 1 mark. Expected for 1 mark. Expected for 1 mark or 3 marks also. 3 marks also. Because uses they will ask. So next one, HRS high. So next one, next question. So, okay, this question already we discussed. So here these two questions you have to learn. This is for 1 mark. Generally, this question they will not ask. They didn't ask till now. So paraxial rays. Paraxial rays. Paraxial rays. Third one, marginal rays. Marginal rays. And fourth one, so let me know. And use of play concave mirror. So last one is uses of concave mirror. Concave mirror. Concave mirror. Okay. And the fifth one, last fifth one. So 5 questions. Max I'll try to give 5 questions. And use of convex mirror. Uses of convex mirror. Convex mirror. Okay. Uses of convex mirror. Uses of convex mirrors. So uses of concave mirrors. So what are the use of plane mirrors? What are the use of plane mirror? So let me know the answer. So explanation you'll get at so now 9:38. 9:38. So you'll get explanation. Nine explanation. Explanation at the rate of 9:45. Shall I? Because almost 9:40. 5 more minutes. So we'll see how many we are going to how many are going to give the answers. So uses at least two. I'm going to that. Two uses. Two uses you can write. And here also two uses. Two uses minimum. That's when. So what are the uses of plane mirror? At least two uses. So no need to write everything. So minimum two uses, right? Okay, so that's enough. Let me know the answer. Okay, so everyone concentrate on a concept. Don't deviate from the paths. So that is a small request from my end. Come to the point. What are the use of plane mirror? So plane mirror uses, you can see here. What are the plane mirror uses? They are used as looking glass. First one, they are used as looking glass. They are used as looking glass. Okay. First one is looking glass and solar cookers. First one I am telling. So looking glass and solar cookers. First one is looking glass, looking glass, looking glass. Second one is solar cookers, used in solar cookers, solar cookers. Okay, solar cookers. And the third one, construction of periscope and kaleidoscope also. Construction of periscope and kaleidoscope also. Here paraxial rays, the rays which are very close to the principal axis, the rays which are very close to the principal axis, the rays which are very close to the principal axis, those are called paraxial rays. The rays which are away from the principal axis, I am taking here. So the rays which are very close to the principal axis, if you are taking, these are the paraxial rays. These are paraxial rays. So I am taking here. These are the paraxial rays, the rays which are very close to the principal axis, those are called paraxial rays. The rays which are away from the principal axis, those are called marginal rays. Okay, so away from the principal axis means, so edge are like this, you can take. Okay, it's not very close to the principal axis, those are called marginal rays, marginal rays, marginal rays. Okay, so these are marginal rays, marginal rays. Okay, coming to this of concave mirror used in concave mirror. So where you are using concave mirror? Concave mirror or concave mirror is used in torchlight, churchlight, okay, shaving mirror, dentist, and solar cooker to no solar furnace, solar furnace also. Okay, used in torchlight, churchlight once again. So torchlight and searchlights. First one is in torches. Okay. Second one is shaving mirrors. Shaving mirror. Dentist also will use shaving mirror or dentist mirror. Dentist also will use to see the large view of teeth. Dentist used by dentist. Used by dentist. Dentist. Okay. Dentist. So these are the uses. Whereas convex mirror, because it has more field of view, because it has a wide field view, so wider field view. So that's why we are using it as a rear view mirror. Rear view mirror in vehicles. Rear view mirror in vehicles. Rear view mirror in vehicles. Okay, so rear view mirror in vehicles. First point I'm taking. First point I'm considering. Okay, so convex mirror. Used a rear view mirror in vehicles. Rear view mirror. Rear view mirror, rear view mirror. Second one, used in the shop security, or also use a reflecting telescope. Reflecting telescope. Rear view mirror is very very important. It also adds wider field view, wide range field view. That's the reason we can able to see the large view of the traffic behind of us. Okay. So next, used as shop security mirror. Shop security mirror. Shop security mirrors, shop security mirrors. Okay, shop security mirrors. Uses of convex mirror. uh, Tushar, hi. Okay, so that's enough. This is about use of plane mirror, paraxial rays, marginal rays, use of concave mirror and convex mirror, right? So we can go to that. Next question. Next question. So here now, next question. Name the mirror. Name the mirror. Name the mirror which can give which can give first one is an erect and enlarged image and enlarged image of an object. Image of an object. Second one, an erect and diminished image of diminished an erect and diminished image of an object of an object. Third one, an erect and same size image of an object. Image of an object. Okay. So let me know the answer. Let me know the answer. So let me know the answer. So very important. Very important. These 3 points. 3 points. Let me know. Those who know the answer, you can tell me. So this is very easy, right? So that's why I'm giving a explanation at the rate of. So we can go for answer instead of explanation. Answer at the rate of, because it's very simple. 9:58 p.m. 3 more minutes. Now 9:55. So 9:58 I'll give explanation. Let me know. Those who know the answer, just you can type in the comment section. So we'll see. Later you can check the answer. So until 9. So hi everyone, welcome to the class. So 3 more minutes, try to answer it. Name the mirror which can give an erect and enlarged image of an object, an erect and diminished image of an object, an erect and same size of an object. Once again, name the mirror which can give an erect and enlarged image of an object, an erect and diminished image of an object, an erect and same size of an object. Very important. Okay. So by seeing this one now, we can understand the mirror, what type of mirror it is. Funny, you can ask your doubt. What is your doubt? So those are saying the answers. Okay, I will give the final answer. You can check once. Okay, movie edits. Very good. JEDX movie edits. Yours funny, you can ask. Practice session, I will interact with you all. So that time you can ask, no problem. Thank you, Rangel. Definitely. Gautam, hi. Okay, so we'll discuss the question. We'll see. Now you can see here. Very good, Gautam. So you can check my channel. So you'll get a lot of videos related CBSE Grade-10 physics. You can check the live classes also. Here you can see an erect and enlarged image of an object. See, you can observe your an erect and enlarged image, an erect and enlarge. In concave mirror, last case you can see concave mirror last case, pole, focus and center of curvature. If you place the object between pole and focus, if the place the object between pole and focus, the image will form here. So their image will form this the virtual erect and enlarged image. An erect and diminished image of an object. Erect and diminished image of an object if you are considering here. So this the pole, focus and center of curvature. Light rays are coming here. After reflection, though light rays will meet. Not only this case, another case also you are considering here pole, focus, center of curvature. If you are placing the object also, the image will form at okay between P and F. So image will form here. So what is this mirror? Concave mirror. Concave mirror. Concave mirror. First one. Coming to the second one is convex mirror. Convex mirror. Convex mirror. Convex mirror. Coming to the third one. Coming to the third one. Third one is Third one is an erect and same size of the image. So if you are taking here plane mirror, in plane mirror, if you are taking the object is here, one light I am taking like this, so another light I am taking like this. So here I am considering this the formation of the image. So that is virtual erect and same size. Virtual erect and same size. So if you are extending this light rays and if you are extending this light rays, okay, so I'm considering here and this one. So if you are extending this light rays, extending, then image will form. So here in this case, AB and A dash, B dash. So now third one is plane mirror. Plane mirror. Third one is plane mirror. You can observe here. So first one is concave mirror. Second one is convex mirror. Third one is plane mirror. This is the answer for this question. So if you have any doubt, you can ask. Right? So next one. Next one. I'll explain. Yes, I'll give the questions. Work out on it. Then I'll work. I'll explain. Okay. Then ready. So this question, 1 mark question, important. Each and every question carries 1 mark. So try to prepare. So first question is question number 1. So very simple this one, but still. So two questions I'll give. Try to use it. Solar furnace, already this one explained. Okay, so we'll go to another one. So whatever I'm going to write, that question is very, very important. We need to discuss, but little long. But still I'm writing. So try to answer it. So here I'm considering. So first one is top part of the mirror. Top part of the mirror. Second one, middle part of the mirror. Middle part of the mirror. Middle part of the mirror. And the third one, bottom part of the mirror. Bottom part of the mirror. Okay. So answer these questions. Answer these questions. Okay. One more question I'll write. One more question. Very, very important question. Very, very important question. But we have to discuss. That's the reason I'm discussing. But answer similar one only you'll get. So I'm taking this one. Question number one. Question number one. Question number two. So this question also 3 marks. So this question is very important. This they will come for 3 marks. This also they will come for 3 marks. Okay, na? Just make sure that you are. So explanation you'll get explanation or answer. So I'm writing answer at the rate of 10:15. I'm going. Okay, Narshan, it's fine. So, Pragati, thank you. And shall we go only last 2 minutes? Those who are, you can try to answer it because it's very easy, simple only. Okay, then I'll copy. So, remaining students, those who know the answer, you can. So, these two questions are very, very highly important, expected for exams. So, how can you identify the three types of mirrors? Three types of mirrors. How can you identify the three types of mirrors without touching the mirror? Without touching. Here, a man standing in front of mirror finds his image having very small head, fat body, and legs of normal size. What is the shape of top portion, middle portion, bottom portion? So I'm interested to teach. So that's why I'm going with that. Oh, explanation also notion very good. Oh, fine. Then we'll start the explanation. See here, you can see, observe. Very, very important. Very, very important. I'm explaining this question, 3 marks question. As I'm saying, this is very, very important. 3 marks, 3 marks, 3 marks. This also 3 marks question. Highly important question these two are. That's the reason. See, we can get in previous question also similar to these questions. These two questions and previous question. Same maximum similar question, but the way of asking is different. So a man standing in front of the mirror finds his a very small head. Small head. So man small head and fat body. Fat body I'm taking fat body. Okay, fat body like this, and legs of normal size. Legs are normal size like this. Legs are normal size. Okay, so here like this. So what is a mirror? What is a mirror? What is a mirror? So like here, top portion of the mirror. Top portion is concave mirror because image will be always. So in convex mirror, small head. Small head means always mirror forms virtual erect and diminished image. Virtual erect and diminished image. So convex mirror. First portion is convex mirror. So top portion I am taking here only. Convex mirror. Middle portion is here. Where is it? Fat body. Fat body means, so we can see enlarged image. Enlarged image we will get concave mirror. Enlarged image will get in concave mirror. Concave mirror. In concave mirror, enlarged image will get. So coming to the bottom portion is same. In plane mirror, virtual erect and same size will get. Virtual erect and same size. Only in plane mirror, virtual erect and same size. So bottom portion is plane mirror. Plane mirror. So this is the answer. This is the answer. So this question also, the way of asking is different, but same question. Same question. Okay, same answer. Same answer. So question is different. The way of asking is different, but answer is same here. See, how can you identify the three types of mirrors? Three types of mirrors without touching it. Without touching it. Without touching it. Without touching means, so first mirror, concave mirror. Concave mirror image will form virtual erect and enlarge. Convex mirror, virtual erect and diminished. Coming to the plane mirror, so virtual erect and same size. That's enough. By seeing the image, we can understand what type of mirror it is. So concave mirror, virtual erect and enlarge. Virtual image only. All images are virtual images only. Virtual image. Virtual image. So in concave mirror, enlarge we will get. Enlarged image will get. So convex mirror, diminished image, virtual erect and diminished, virtual erect and diminished, virtual erect and diminished, plane mirror, virtual erect and same size, virtual erect and same size. That's enough. So by this one we can understand the mirrors. We can understand the mirrors. Very, very important, highly important, most important 3 marks question. So very, very important question this one. This one and this one. A man standing in front of mirror finds his image having very small head convex. So fat body, concave, and normal size of legs, plane mirror. So how can you identify the three types of mirrors without touching? So you should know without touching. So you can identify. Okay, so very, very important. Make sure that you are preparing this one. Clear? So you can go back to the live and check once. Now I am working in the student brand, my own institution. So mine only student brand. I am working for my own institution. So if you like the content, do like, share and subscribe to student brand. So you'll get updates regarding the class and live classes, videos. Okay. Yes, Funny. I will explain your doubt. So check once. Your doubt is yes. So I hope it is very clear. So I am rubbing the board. Just check once. So one person asked the question. The question is, one side is concave lens, another side is convex lens. How does the light ray scatters? Actually here, so it is about curvature. So how the curvature is there, how the light rays are passing. Okay, how the light rays are passing. So if you are taking here, scatter means away from the principal axis. That's enough. Away from the principal axis, moving away from the principal axis. So that is only. So instead of converging, it should move away from the principal axis. So how does it happen? I will explain now. One side is concave lens, another side is convex. So that only your doubt, right? Yes. Now we can see. So here, for that we need to understand two phenomena. One is, if you are taking the convex lens, light rays are coming from this, what happens? It will become parallel. So it will move, though light rays are moving away from the principal axis, if the light rays are coming from the focus. Okay. Yes or no? Best example, magnifying glass also you can see in reverse manner if you are taking. Okay, next one, parallel beam of light will get. So second one, concave lens. This is the concave lens. Okay, concave lens. Light rays will come here. So the light rays are coming like this. If the light rays are coming like this, okay, from one point, if the light rays are coming, what happens? Anyway, if the light rays are coming, passes through the focus like this. So it will diverge. Light rays are coming, it will diverge. Okay, so if you are taking light rays are coming from infinity also, even if the light rays are coming from infinity like this, if the light rays are coming from infinity, okay, it will diverge, right? So we'll combine these two. If you are taking concave lens I'm taking like this, and here also concave lens, and this side is convex lens outside. So actually convex lens is a converging lens. This is a concave lens is a diverging lens. Suppose if the light rays are coming from this focus, okay, what happens? It will diverge the light rays. So it diverge the light rays. So it will diverge the light rays. Actually, by coming here, so because of the curvature, after coming here, after coming through this one, so it will become like this. And here also after coming like this, so after coming through the surface, here also surface is there, here also surface will be there. So after coming like this, it will become, then it will be, so the light rays will move away from the principal axis. Away from the principal axis. Is it clear? Is it doubt or clear? Doubt is clear? It was funny. If it is clear, let me know. Shivam Kumar, hi. Pragati, thank you. I am medical student studying seeing this type of lens. So just wanted to learn the basic before proceed. Oh, oh, thank you, Funny. Thank you so much. Is it clear? So if you like it, just click a like button. That's it. Thank you so much. You can attend my class. Daily you'll get the concepts at the same time question and answers. So more in depth will go. Till now, these many days I explained the concept to understand. See, students will learn one class. So after some time one more class. After some time one more class. So coming and going. That's the reason. So these many days I explained completely concept. So I hope so people will understand. That's the reason I'm explaining. Now we are going into the question and answers in depth of the topic. Okay, and where the questions will come, and what type of how they will ask in exam. Okay. Okay, coming to the next one. Next, one more question. One more question. So shall we do problems? Now theory questions completed. Try to do the problem. Then, so be ready, everyone. Try to do the problem. See, I already explained the concepts, sign conventions. So many times I explained. I, I sang the songs also. Okay, so you can watch those videos. Question number one. An object, an object, an object is placed, an object is placed in front of a concave mirror, in front of a concave mirror, concave mirror, concave mirror of focal length, of focal length, of focal length, so 30 centimeter. So the virtual image is, the virtual image is, the virtual image is, virtual image of the object, virtual image of the object is obtained, is obtained at a distance, at a distance, at a distance 20 centimeter, 20 centimeter from the mirror, from the mirror. Calculate the position of the object. calculate the question, calculate the position of the object, position of the object. New Cartesian, sign convention, new Cartesian, sign convention. Our distance are measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. So come on everybody, try to answer it. So explanation will get at 10:34. So last 1 minute. Pranjal already explained. So he said thank you also. I hope you didn't see that message. Just check once. Okay, so ready for the answer. So here you can see, as I said, so you have to first underline Manish Kumar. Okay, try to answer it here. An object is placed in front of concave mirror. Underline the few points. So where we can able to solve 50% of the problem. If you identify few points, those are, one is mirror. First one related to mirror problem. First identify the mirror, which mirror is given. Sometimes they won't give, so there only will get confusion. So that's why first you have to identify the mirror. Second one, object distance. What are the mirror, what are the lens you consider? Object distance always negative. Object distance always negative, because object must be placed in front of the mirror itself, right? Whether you are taking concave mirror, convex mirror, or plane mirror, so anything you take, you have to place the object in front of the mirror. So compulsory object distance must be negative. So here focal length is given. Focal length of concave mirror is negative. Sign conventions, very, very important. Third point, focal length. Focal length is positive for concave. For convex, it is focal length is negative for concave, positive for convex. Sir, how can you say like that? So normally I already said. So sign conventions. So this side for concave mirror, focal length will be here, focus to pole. For convex mirror, so the focus will be this side. So from the pole along the incident rays direction. So here opposite to incident rays. So focal length is negative for concave, focal length is positive for convex. Here focal length is negative for concave mirror. Yes. Sumaya, very good, correct only, good. Focal length for concave mirror is negative. Okay, so next one, they're asking to find out the virtual image of an object is placed at a distance of. So what is this one given? Object distance or image distance? Let me know. Object distance or image distance? Object distance or image distance? Here the virtual image of an object obtained at a distance of from the mirror. Virtual image of the object is obtained at a distance of 20 centimeter. Virtual image. Virtual image. Say given virtual image. What is the meaning of virtual image? Virtual image is positive. Sorry. So virtual image is positive. Plus 20 centimeter. Plus 20 centimeter. I will write once again. So just for indication I am telling. So what are the points we need to follow? We need to identify before solving the problem. First you have to identify the mirror. Second you have to identify object distance anyway always negative. If they give value, happy. If they didn't give also, no problem. We can find out. Okay. So now you can see here. So focal length is given first given data. One problem I will explain in a proper way. So next problem onwards you try to do it. So theory you have to write in the same format. Given data, focal length you have to write. So focal length is given how much? Focal length is anyway for concave mirror negative focal length 30 centimeter. So next one, image distance is given plus virtual image. That's the reason they given plus virtual image. If they mention virtual image will form above the principal axis, that too concave mirror. Immediately you should identify the position also. If they mention virtual image, immediately the position of the image also you should get in your mind. Immediately that should strike in your mind. Okay, so where the object position, so image must be formed here. So here one thing you need to understand, focal length is given 30, image where we need to place the image to get, in order to get the virtual image, we have to place between f and p. F and p in the sense less than focal length, only. Okay, less than focal length, sorry, it's greater, less than focal length must be greater coming compared to x, means object distance. Like you can take q also, object distance must be smaller compared to focal length. That condition is very important. That condition is very important. If you know this, then problem is easy. You have to check like this, you have to verify the problem like this. You must understand how the object is placed, how the image will form, what type of image will form, where the object is, what is the focal length. So how to get the image, what is the nature of the image, everything you should know by seeing the diagram. You should get it the diagram immediately after seeing data. After seeing the data, immediately you should get the diagram. So in your mind you should get the diagram, then only it is correct. Then only you can verify further. So in future, after solving the question, you can understand. So you can check whether you did the correct one or not. Okay. So now I'm doing the problem. Check once. So the final answer must be object must be negative, that too between P and F. That we need to get it, right? So how to do it, you can check. So I'm considering some x I'm considering. Now we'll see. Means less than 30 you should get. That is a condition. Now formula is 1 by F equal to 1 by U plus 1 by V. So we know two values. Focal length we know, image distance we know. We can find out the object distance. 1 by minus 30 equal to 1 by U plus 1 by 20. If it is goes that side, 1 by U equal to 1 by minus 20 minus 1 by 30. Okay, let it be 1 by minus. So minus 1 by 20 minus 1 by 30. So how much is LCM? Try to solve the LCM. How much is LCM? LCM 60. LCM is the 60. So 1 by U equal to 60. So minus 3 minus 2. Then you will get minus 5 by 60. Then U equal to minus 60 by 5. How much? Minus 12 centimeter. Is it correct or not? Now so with the confidence you can write the answer. With the confidence. So you no need to worry about it. So whether I did correct or not. So you no need to worry about it. Confidently you can write. So why I am saying that much confidence? Point number 1. Object distance must be negative. Point number 2. So object distance must be below the or less than the focal length. As we already know this condition. So less than focal length. So focal length is 30. So we got object distance is minus 12. Is it correct or not? Yes or no? That's enough. Like that we have to do it. Like that we have to understand the question. Yes or no? So this is the way, this is the process to do the problem. I'll give one more problem. Yogesh. So I already said now object distance always must be negative. It cannot be positive. Object distance should be always negative. That is 100%. Okay, so next one, we are going to the next one, next problem. Next problem. So we are going to the next problem. Try to solve this problem. Answer is 12. So I am taking the magnitude. Magnitude is 12. Object distance. Object distance I am saying magnitude. Magnitude is object distance is 12. So sign you can take negative. That is the answer what I am going to say. That x is the distance, not sign. That is x is the distance. Pranjal, that is x is the distance, not with sign. X is only distance. How much distance I am saying? From pole to focus. So sign automatically it is minus. Minus. So you have to plus 12. You have to place 12, not minus 12. Is it clear? Okay, it's okay, fine, no problem. It's okay, fine, no problem. I'll have few more to do. You'll get clarity. Pranjal, don't worry about it. Yeah, I can. So that is a major issue for everyone. So it's okay, no problem. We'll do it. Don't worry about it. So we'll do more problem. Then you'll get. So explanation you'll get 1055. Explanation at the rate of 1055. Answer. Okay, Roshan. Carry on. Uh, Correct, Sumaya. Sumaya is that is correct. Here they given a convex mirror, so answer is correct. Okay, Pranjal, definitely I will discuss. I'll discuss very clearly. Little more I will discuss. Don't worry about it. Still time is there. I will little more in depth. I will discuss. So Anil, the last 1 more minute. Uh, no, it is 15 by 3. 15 by 13 is correct, Anil sir. 15 by 13, that is 1.15 meter. Anyway, I'm going to explain, right? Answer is 1.15. 15 by 13 is correct. You already given in the first message, I hope. First or second message. Yours first or second message, you given that. Sangeeta saying thank you so much. Okay, done. Shall we start? Ready? So few points I will tell. So keep in mind. So only focus when you are doing problems on mirrors. Focus on sign conventions of mirrors. Okay. So don't think about any other points. So I'm considering here. Here you can see a convex mirror. So convex mirror. I already said underline the mirror. First point. Used as radio mirror in car as radius of curvature. Radius of curvature is given R. Very good. If an approaching bus is located at distance, the bus also placed. So that is nothing but object distance. This is radius of curvature from this mirror. So how far its image appears in the mirror? First point is image we need to find out. How far image they are asking to find out. Image we have to find out. Yes or no image. So here I already said convex mirror. If it is convex mirror, focal length is. So here whatever the required points we'll discuss, necessary points what we have, what we need in this question only related to this question are related to convex mirror only I will tell. So object distance anyway negative only. Anyway whether they will give or whether we are getting or not, so it must be negative. It must be negative. First point. Second point. Second point is focal length must be positive. Convex mirror already said. This is the convex mirror. So I already said if you are taking the mirror, it is a part of the sphere. So we are taking this is center of curvature. So this is the focus. So here light rays are coming. All light rays must be taken in the direction of incident rays, opposite incident rays negative. So in the incident rays direction positive. So I am explaining sign conventions. Once again listen carefully. This is the convex mirror. So pole, focus, center of curvature. So in this direction all measurement must be conceived from the pole along the incident rays direction. Object distance, image distance, focal length, radius of curvature all are positive. Opposite to incident rays, object distance, image distance, focal length and radius curvature. Object where we have to place object always anyway in front of the mirror only, right? So leaving the object this side, remaining all are positive. So in this case object anyway we have to place this side, object distance must be negative and image distance, focal length, radius of curvature. Anyway in convex mirror image will form this side, so image must be positive. So focal length also positive and radius of curvature also positive. So blind you have to fix it. You have to fix these conventions according to the rules and regulations, according to the concept only we are following. Okay, we are not doing anything, so we are not creating any new rules. So we are following the concept, we are following the textbook. You can read the textbook once, you can check the textbook once. So according to the textbook, according to the concept, we are following same concept. Okay, no changes at all. So go through that one, check the concept, let me know if any changes are there. Okay, so in the direction of incident rays, object distance, image distance, focal length, radius of curvature all are positive. All are positive. So here in this question, what are the values are given? Radius of curvature is given. Positive or negative? Positive. Radius of curvature positive, then focal length also positive. So object distance anyway negative. So you know two values. Focal length you know, Object distance, we can find out the image distance. In this case, in convex mirror, image is positive or negative? Compulsory you should get positive value only, because image is positive. While after doing the problem, after completion of the problem, still you have to check with this method. Okay, you have to check whether you did the correct one or not. Okay, fine. So now we are going to the next one. Now you can see, now object distance, how much is given? Object distance is minus 5 meter. So radius of curvature is given 3 meter. Focal length is 3 by 2. That is nothing but 1.5 meter focal length. Okay. So we know two values. Anyway, it is positive only. You don't need to do anything. So mirror formula, 1 by F equal to 1 by V plus 1 by U. What we have to find out? We have to find out image distance. Yes, object distance already given. Now bus only object distance. So image distance we have to find out. Image distance we have to find out. So 1 by F is nothing but, so you can take this value. So I will tell one small logic. So you keep it 3 by 2 as it is like this. Instead of substituting 1.5, I will tell. So why you are asking me to substitute only 3 by 2? Why can't I go for 1.5? While calculation you will get problem. While doing calculation you will get problem. That's why let it be 3 by 2. So it is small logic to do the problem. So I am taking, so 1 by 3 by 2 equal to 1 by, so image distance we have to find out, by 1 by minus 5. Yes or no? So you are taking minus value that side, then you will get positive. So this will come 2 by 3 plus 1 by 5 equal to 1 by V. Yes or no? Now if you solve it, sorry. Okay, now you are solving. So 1 by V equal to, so if you are taking LCM 15, 5, 10 plus 3, then 13 by 15. Then V value equal to reverse of it, 15 by 13. Meter or centimeter? Meter only, because everything we are substituting in meter, right? See how easy it is. So try to substitute. See, a calculation you should solve in a simple way. So you should not make it in complicated manner. Because while solving, if you are not getting the answer, so what happens? You will get headache, you will get frustration. Oh my god, this is physics, I can't able to do it, so I'm getting frustration. After solving many times also I'm not getting answer. What I have to do? So you will leave simply, you will keep books aside, then you will do other works. That is the reason. Make it very simple, very simple, in easy way. So very least possible way you have to make it. Okay, you have to make it. Then only you'll get the answer. While calculation, what you'll go for maximum possible way to cancel the values, right? Here also least possible way to make it. Okay, now. So make it very simple. Simple calculation, easy calculation. If you substitute 1.5, so again it's a problem, right? So you have to multiply 10 by 10. Again you have to take. So that is your choice. So the steps will multiply again and again. That is the reason. Is it clear? If you have any concern, so Pranjal, is it clear? Answer is 15 by 13, that is 1.15. Answer is 1.15. V is, if you solve still, you will get 1.15 meter. Is it clear? Do you have any doubts? If you don't have, at least I got it, sir. Yes, sir. Like that, if you say, I'll I can go to the next problem. Okay. Okay, then we are going to the next question. So try to do the next question. Okay, done. So we are going to the next question. Okay, so shall we go for homework? This question. Will you do homework and let me know in the comment section after the class? Shall we do it? Try this question as a homework. Try to do in comment section below. Okay. So tomorrow we'll do more questions. We'll discuss more problems and more concept related questions also. So that's enough for today class. Thank you so much for joining and listening, attending, interacting with me all. So thank you so much. If you like this video, if you like my content, if you like my explanation, if you like the Student the Brand channel, please do like, share, and subscribe to Student the Brand. You can inform to your friends, ask them to come and join to the class. So now live class timings 11 a.m., 3 p.m., 11 a.m., 3 p.m., 6 p.m. and so I'll be writing the timings also. Try to inform your friends, ask them to join. Okay, so you can see every day. First one is 11 a.m. 11. Second one is 3 p.m. So live class timings around 3:30. So only this will change. Around 3:30 I'll take. So this class around 3:30 p.m. Third one 6 p.m. live class timings every day. Every day live class. Come and join and discuss with me if you have any concerns. So ask your friends to join. Inform your friends regarding the class. So and regarding the timings of live class. So thank you so much. Thank you so much. This is your sir from Student the Brand. So do like, share, and subscribe to Student the Brand. Thank you so much. We'll see in the next class.